In this video, we will discuss about homologous series. So what is a homologous series? A group of organic compounds having similar structures and chemical properties are called homologous series. Now let us see the characteristics of homologous series. All the members of homologous series are represented by the same general formula. Obviously, if they have similar structure, they have to be represented by the same general formula too. Any two adjacent homologues differ by a CH2 group. So, if there is a homologous series, then any two homologues present in that particular series will differ by a CH2 group, but they have to be adjacent. The difference in the molecular masses of two adjacent homologues is 14 mu. So again, in a homologous series, if we consider two adjacent homologues, then the difference in both of their molecular masses is 14 mu. All the compounds of homologous series show similar chemical properties. That is mentioned in the definition itself, that they have similar structures and chemical properties. As usual, so all these compounds which are present in the homologous series will show similar chemical properties. The members of homologous series show a gradual change in the physical properties with the increase in molecular masses. So as we have discussed, there is a change in the molecular mass, that is between two adjacent homologues, the change is 14 mu. So as this molecular mass increases, there is a gradual change in their physical properties. So as the increase in molecular mass takes place, there is a gradual change in their physical properties too. Let's now check out an example. So if you can see here, CH4, C2H6, C2H6 and C3H8. So these are two examples. So let us look at the first one, CH4 and C2H6. So in these two, they are differing by a CH2 unit. If you can see here, there's one carbon, two carbons. So 1C difference, and there are 4 hydrogens here and 6 hydrogens here. So 2 hydrogen difference. So they're differing by CH2 unit. Again, if you take the second example, that is C2H6 and C3H8. So if you can see this, it is 2 carbons here and 3 carbons here. So 1C difference, and it's 6 hydrogens here and 8 hydrogens here. So there is 2 hydrogen difference. Again, differing by a CH2 unit. So we can say that these are homologues which differ by a CH2 unit, and they form a homologous series when arranged in an order. Now let us check out something very interesting. So initially we thought of alkanes, alkenes and alkynes. So alkanes are saturated ones and alkenes and alkynes are unsaturated ones. So for all these, a general formula is given. That is, for an alkane, the general formula is CnH2n plus 2. So let us take an example. The example is methane. So meth means 1. So you have to substitute the number in the place of n. So now methane is 1. So substitute 1 in the n's place. In this n and this n. Now what do you get? C into 1, that is C. H into 2 is H2. Into 1 is again 2 plus 2, 4. CH4. So the formula of methane is CH4. So like that, let's move on to unsaturated ones, that is alkenes, the ones with double bond. So the general formula of alkene is CnH2n. So let us take an example again, ethene. Eth means 2. So let's substitute 2 here. C into 2 is C2. H into 2 into 2 is 2 into 2, that's 4. So it's C2H4. So for ethene, the general formula is C2H4. Now let's look at alkynes which have triple bond. So again take example of ethyne. Ethyne. Eth again 2. So substitute 2 in the place of n. C into 2 is C2. H into 2 into 2 is 4. H4. Minus 2 is 2. So the formula is C2H2 for alkyne. So this is how you'll calculate alkanes, alkenes and alkynes general formula through this. Now let's look at another example to understand better about homologous series. So if you can see, these are different compounds: CH3OH, C2H5OH, again C2H5OH, C3H7OH, again another one, C3H7OH, C4H9OH. Can you just find any similarity between this example, and this example? Yes, all of them differ by a CH2 unit like these examples. If you can see here, there is one carbon here, two carbons here. So one carbon difference. There is three hydrogens here and five hydrogens here. So two hydrogen difference. So differing by a CH2 unit. The same here, it is two carbons and it's three carbons here. So one carbon difference, it is five hydrogens and seven hydrogens here. So two hydrogen difference, which is again a CH2 unit difference. Here, if you can see this last example, it is three carbons and it's four. So one carbon difference. So here seven hydrogens and nine hydrogens. Again, two carbon difference. So again, they are differing by a CH2 unit. You might get confused, like why are we not adding up this hydrogen? This is an extra issue that you will have to deal up. So this is not a hydrogen, this is a functional group. OH is an alcoholic functional group. So this you cannot consider it as hydrogen separately, but it is OH combined together to form a functional group. So you cannot add up these hydrogens. So what are they all about? They are just differing with a CH2 unit. Now, let us arrange all these compounds in increasing order of carbon atoms. So these are the compounds we have. So if we arrange all of these homologues, we will get sequential homologous series. So we will arrange them with the increasing order of carbon atoms. So see, one carbon atom, two carbon atom, three carbon atom, four carbon atoms. So I've arranged it according to the increase in the number of carbon atoms. So what do you find here? This is a homologous series. So the homologues, which are arranged in the sequential order with the increasing number of carbon atoms, form a perfect homologous series. Thank you.